In 1833, a wooden sailing ship arrived in Calcutta carrying a cargo that should not have survived the journey. The ship had spent roughly 4 months at sea. It had travelled thousands of miles from Boston, crossed the equator, rounded the southern end of Africa, crossed the equator again, and entered one of the hottest cities in the British Empire. Inside its hold were blocks of frozen New England pond water. No refrigerator kept them cold, there was no electric compressor, no refrigerated container, and no mechanical cooling system hidden below deck. The ship had left Boston carrying approximately 180 tons of ice. By the time it reached India, around 100 tons remained. The rest had literally disappeared. Yet the surviving ice was valuable enough to make the voyage worthwhile. This was the central problem of the natural ice industry. Its product destroyed itself every minute it remained unsold. A merchant could purchase grain and store it for another season. He could stack timber in a warehouse or leave coal sitting beside a dock. But an ice merchant owned inventory that was constantly turning into water. And somehow, during the 19th century, businessmen transformed that disappearing inventory into an international industry. This is the economics of ice before refrigeration. Before ice became a commercial product, wealthy families in Europe and North America already understood that winter could be stored. Large estates sometimes had private icehouses, underground pits, or thick-walled structures where blocks of winter ice were packed together and covered with straw. The ice could survive into summer because heat entered slowly. A large mass of tightly packed ice had less exposed surface area than hundreds of small pieces. Thick walls delayed warm outside air. Straw trapped pockets of air, and air is a poor conductor of heat. Proper drainage removed meltwater before it could transfer additional heat into the remaining blocks. But this was a private convenience, not yet a complete economy. The owner of an estate could cut ice from a nearby pond, store it on his own land, and use it in the same location. Commercial ice was much more difficult. A business had to harvest thousands of identical blocks, move them without breaking them, store them for months, transport them to distant customers, and still have enough remaining to sell at a profit. The most famous person to attempt this was a 23-year-old Boston merchant named Frederick Tudor. Tudor saw something economically unusual in the frozen ponds of Massachusetts. During winter, nature produced an enormous quantity of ice without charging anyone for the cold. In tropical cities, however, ice was almost impossible to obtain. The difference between those two places created an opportunity. In Massachusetts, frozen water appeared to be nearly worthless. In the Caribbean, the same frozen water could become an extraordinary luxury. Tudor did not need to manufacture his product. He needed to transport winter from a place where it was abundant to a place where it did not naturally exist. The idea sounded simple until he tried to hire a ship. Ship owners worried that the ice would melt inside the hold, flood the vessel, and damage other cargo. Many thought the entire scheme was ridiculous. Tudor eventually had to acquire a ship himself because established merchants did not want to risk their vessels on what appeared to be a cargo of water waiting to happen. In 1806, his first major shipment left Boston for Martinique. The voyage proved that ice could survive a journey to the Caribbean, but it did not prove that ice could make money. Tudor arrived with no mature distribution system, no reliable local icehouse, and very few customers who understood what to do with the product. This revealed the first major economic problem. Ice was not simply a product, it was a system. If Tudor delivered a block to a customer who had nowhere insulated to store it, the block melted. If a tavern owner placed it in an open room, much of its value vanished before it could cool enough drinks to recover its cost. If the receiving port lacked an icehouse, the entire shipment had to be sold immediately, whether demand existed or not. Tudor therefore had to build the infrastructure that made his own product useful. He needed storage buildings at the destination. He needed trained agents who could divide and sell the blocks. He needed hotels, restaurants, and wealthy households to understand the value of cold drinks, frozen desserts, and food preservation. He occasionally encouraged businesses to experiment with ice, because once customers became accustomed to cold beverages, warm ones felt inferior. He was not merely satisfying demand, he was teaching the market to demand something new. That made his early business expensive. Tudor lost money, accumulated debt, and even spent time in debtor's prison. His problem was not that people disliked ice after using it. His problem was surviving long enough financially for ice consumption to become a habit. The raw material might have been inexpensive, but almost everything surrounding it cost money. Workers had to be hired during a narrow winter harvesting window. Horses, saws, cutters, and hauling equipment had to be maintained. Icehouses required land, timber, insulation, and enormous structural strength. Ships had to be purchased or chartered. Agents had to be paid in distant ports. Melted ice still occupied cargo space at the beginning of the voyage, but produced no revenue at the end. The economics therefore depended on one number more than any other: the percentage of the cargo that survived. If 100 tons entered a warehouse and only 34 tons remained when customers arrived, the surviving 34 tons had to carry the cost of harvesting, storing, and losing all 100. But if improved insulation allowed 92 tons to survive, the cost attached to every sellable ton dropped dramatically. Reducing melting loss was equivalent to lowering the cost of production. Tudor experimented with different insulating materials and storage designs. One of the most effective materials was sawdust. To a lumber mill, sawdust was waste. It occupied space and had little commercial value. To an ice merchant, it was a cheap blanket filled with countless pockets of trapped air. Packed around blocks of ice, it slowed the movement of heat. This created a beautiful economic relationship between two industries. The lumber business produced unwanted sawdust. The ice business needed inexpensive insulation. A waste product in one supply chain became an essential input in another. But sawdust alone was not enough. An icehouse needed thick, often double walls, with insulation packed between them. It needed a roof that limited heat from the sun. Some large icehouses were painted white to reflect sunlight. The floor had to be designed so meltwater escaped rather than collecting beneath the ice. This last detail mattered because water transfers heat far more effectively than still air. Leaving ice sitting in meltwater could accelerate the destruction of the inventory. A successful icehouse did not prevent melting entirely. It controlled where the heat traveled and removed the water produced by unavoidable losses. The blocks also had to be packed tightly. Every crack between blocks allowed warmer air to circulate. Irregular pieces wasted storage volume and exposed more surface area. Perfectly rectangular blocks could be stacked almost like bricks, creating one enormous frozen mass rather than thousands of separate pieces. That required a better harvesting system. At first, workers hacked irregular chunks from ponds with axes, chisels, and saws. It was slow, dangerous, and wasteful. Then inventor Nathaniel Jarvis Wyeth developed a horse-drawn ice cutter, patented in 1829. A horse could pull the cutter across the frozen surface, scoring long, straight grooves into the ice. Workers repeated the process at right angles, producing a giant grid. The sheet could then be separated into long strips and divided into uniform blocks. This did more than reduce labor. Uniform blocks were easier to calculate, easier to transport, easier to stack, and less likely to leave warm air gaps inside the icehouse. Standardization reduced losses at almost every stage of the business. The pond began to resemble a frozen factory floor. First, workers removed snow because snow insulated the ice and concealed its quality. They inspected the surface and measured its thickness. At major operations, companies often waited until ice was roughly 14 to 16 inches thick. Horse-drawn cutters marked the grid. Workers deepened the grooves with plows and saws. Long rows of blocks were guided through channels of open water toward the icehouse. Men used hooked poles to control them, while elevators or inclined ramps lifted the heavy blocks into storage. At some operations, hundreds of seasonal workers could fill enormous icehouses in only a few weeks. The work was wet, exhausting, and dangerous. Men stood on a surface they were deliberately cutting apart. Horses could slip or fall into open channels. Blocks could crush hands and legs. A single large piece of ice was heavy enough to cause severe injury, and workers had to move thousands of them while racing against changing weather. The harvesting season was short because the company faced two opposite risks: harvest too early and the ice might be too thin to support workers, horses, and machinery. Harvest too late, and warmer weather could soften the product or end the season before the icehouse was filled. A cold winter created inventory. A warm winter created an ice famine. That made natural ice a weather-dependent commodity. Companies could invest in horses, buildings, and delivery wagons, but they could not order another freeze when supply was low. A failed harvest could send prices upward. An unusually cold year could fill every competitor's warehouse, create excess supply, and push prices downward. Once the blocks entered storage, scale became an advantage. A small merchant might lose a greater proportion of his ice because a small pile had more exposed surface relative to its volume. A large company could pack thousands of tons into an enormous insulated building where the outer layers protected the ice deeper inside. Large operators could also spread fixed costs across more inventory. The same dock, elevator, manager, and delivery network could handle far more ice without costs rising at exactly the same rate. This encouraged the industry to become larger and more concentrated. But before companies could dominate cities, someone still had to solve ocean transport. Ships presented a strange combination of advantages and risks. Boston merchants often sent vessels toward the Caribbean to collect valuable return cargo. Some ships would otherwise begin part of the journey with unused capacity, making freight space relatively affordable. Ice could therefore be loaded into space that might have earned little revenue. The cargo was packed below deck in large, tightly arranged blocks and surrounded with insulating material such as sawdust or hay. A ship carrying ice became a floating icehouse. But the merchant was not paid for what left Boston, he was paid for what reached the destination. Every day at sea reduced the sellable weight. Delays, storms, poor packing, and warm air entering the hold all consumed the cargo. A captain taking an unnecessarily slow route was not merely wasting time. He was watching his customer's inventory become part of the Atlantic Ocean. Speed had a financial value measured in tons of surviving ice. The smartest merchants also understood that a melting cargo was not automatically an unprofitable cargo. What mattered was the relationship between the loss rate and the destination price. Suppose 100 tons were loaded at relatively low cost in New England. If only 60 tons survived, but those 60 could be sold at several times the northern price, the voyage could still work. The lost 40 tons were effectively part of the transportation expense. This is why tropical markets were so attractive. They offered the greatest difference between the original value of the ice and its final selling price. Tudor gradually established operations in the Caribbean and Southern American cities. His techniques improved, his destination icehouses became more effective, and consumers learned what reliable ice could do. Then he attempted something far more ambitious. In 1833, the ship Tuscany sailed from Boston toward Calcutta, carrying roughly 180 tons of New England ice. The voyage was around 16,000 miles and took approximately 4 months. The ship had to pass through tropical conditions and cross the equator twice. By the time it reached Calcutta, around 100 tons reportedly remained. From one perspective, losing approximately 80 tons sounds disastrous. From another, delivering around 100 tons of natural ice to India without mechanical refrigeration was an extraordinary logistical achievement. The surviving product entered a market where the heat was intense, the supply was scarce, and wealthy customers were willing to pay for relief. Specialized icehouses were eventually constructed in Calcutta, Madras, and Bombay. These were thick, double-walled buildings designed to slow melting in tropical conditions. Imported ice also received favorable treatment from colonial authorities, including duty-free status in British India. This reduced the cost of entering the market and helped the trade continue. But the Indian ice trade also exposed an uncomfortable side of the industry. Ice might have been harvested from nature, but access to it was not equal. Imported ice in colonial cities was initially consumed largely by Europeans, wealthy residents, elite households, clubs, and hospitals. Icehouses served particular districts and customers. Cold became a form of privilege. The value of the product did not come only from temperature. It came from scarcity, social status, and control over distribution. In wealthy homes, ice could chill drinks, support elaborate desserts, and preserve certain foods. In hospitals, it could be used to cool patients with fever, numb parts of the body, and support medical procedures. Hotels and clubs used ice as a mark of comfort and sophistication. A block of frozen pond water had become a global status product. As the industry expanded, however, ice moved beyond luxury drinks. Breweries required temperature control for consistent production. Fish markets needed ice to keep the day's catch from spoiling before sale. Butchers, dairy sellers, and food merchants used ice to extend the useful life of perishable goods. Meatpacking companies consumed enormous quantities. Railways placed ice inside specially designed cars so food could travel farther. The true value of ice was not the cold sensation itself, it was the additional time that cold created. A fish without ice might need to be sold close to the coast and almost immediately. With ice, the seller could reach inland customers. Milk could remain usable longer. Meat could travel from one region to another. A brewery could produce more consistently across seasons. Ice enlarged markets. It allowed a producer to sell to customers located farther away, reduce some forms of spoilage, and weaken the connection between where food was produced and where it had to be consumed. That is why the natural ice trade became part of the foundation of the modern cold chain. By the middle of the 19th century, major companies were no longer treating ice as an unusual luxury cargo. They were operating industrial systems. Rockland Lake, located near the Hudson River, became one of New York's most important sources of clean, natural ice. Its location offered access to the enormous New York City market, while its relatively pure water made the ice more desirable. Purity became a form of branding. Ice cut from a clear lake could be marketed as safer and more attractive than ice taken from a polluted urban river. Customers might not know the chemistry of the water, but they could see the difference between a clean, transparent block and one clouded with sediment. As cities industrialized, pollution made some traditional harvesting areas less suitable. The quality of the source became both a health concern and a competitive advantage. At Rockland Lake, companies built immense icehouses, measuring hundreds of feet in length. During the peak harvest, approximately 400 to 600 workers could spend around 3 weeks filling them. In 1855, New York City purchased roughly 75,000 tons of ice. By the 1880s, the figure had climbed to around 1.5 million tons. This was no longer a novelty for a few wealthy dining rooms. Along the Hudson, companies constructed a network of icehouses, docks, barges, transport systems, and urban storage facilities. The Knickerbocker Ice Company eventually controlled a vast operation that included dozens of barges, hundreds of delivery wagons, and approximately 1,000 horses. Winter had become an industrial raw material. The final stage of the supply chain was the iceman. In cities, horse-drawn ice wagons moved through neighborhoods carrying large blocks beneath insulated coverings. The iceman used tongs to grip a block, lifted it onto his shoulder, and carried it into the customer's home. The destination was not a refrigerator, it was an icebox. An icebox was an insulated wooden cabinet, often lined with metal. One compartment held a block of ice, while nearby compartments held food. As warm air inside the cabinet transferred heat toward the ice melted and cooled the enclosed space. There was no compressor and no thermostat. The household had to purchase new ice regularly, empty the meltwater, and keep the cabinet reasonably clean. Depending on the weather and the quality of the insulation, a block might last roughly 5 days to a week. This created a recurring revenue business. Selling a family an icebox did not eliminate its demand for ice. It locked that household into repeated deliveries. Every new icebox expanded the addressable market for ice companies. The appliance and the commodity strengthened each other. More reliable delivery made iceboxes useful. More iceboxes made delivery routes profitable. Denser delivery routes reduced the distance between customers, allowing one wagon and one horse to serve more households each day. The industry was building a network effect based on geography. A company with only a few customers scattered across a city faced high delivery costs. A dominant company with customers on nearly every street could deliver far more ice with the same wagon, driver, and horse. That encouraged consolidation. Large firms purchased rivals, controlled docks, acquired shoreline property, and fought for access to the cleanest water. Around Rockland Lake, competing businesses bought land around the shore to strengthen their claims to the ice. Later, companies consolidated across the Northeast, producing powerful organizations, sometimes accused of manipulating supply and prices. By the end of the century, ice was essential enough that control of the market could provoke public anger. The product that people once refused to buy had become something cities feared living without. But the natural ice business contained a weakness it could never completely remove. Its factories were lakes, and its production schedule belonged to the weather. A warm winter could leave warehouses partly empty. A contaminated river could destroy confidence in an entire source. A hot summer could increase demand, just as stored inventory was melting faster. A cool summer could weaken demand after companies had already paid to harvest and store enormous quantities. The inventory could not wait indefinitely for a better price. Even a properly packed icehouse lost some product. The business owner therefore faced a decision every season: sell early at a lower price, or hold inventory for hotter weather while accepting continued melting risk. Ice was both a commodity and a countdown. Then a new competitor appeared: ice that did not require winter. During the 19th century, inventors developed machines that could remove heat and freeze water artificially. John Gorrie received an American patent connected to mechanical ice production in 1851. Other inventors improved absorption and compression systems, and ice plants began appearing in warmer cities. Early machines were expensive, complicated, and sometimes unreliable. Natural ice companies could still harvest frozen water cheaply, so many established operators did not initially view artificial ice as an immediate threat. But manufactured ice possessed one decisive advantage: predictable production. An ice plant did not need a frozen lake. It could be constructed near the customers. It could produce ice in a southern city during a warm winter. It reduced dependence on long-distance shipping and allowed companies to respond more directly to demand. Artificial ice also addressed growing concerns about pollution. A plant could use a controlled water source instead of cutting blocks from increasingly contaminated rivers. The economics were shifting from low-cost seasonal harvesting toward higher capital but more reliable local manufacturing. At first, the new technology did not destroy the ice business. It changed who could compete in it. Companies invested in steam-powered machinery, ammonia systems, brine tanks, compressors, and later electric motors. Instead of waiting for a pond to freeze, plants froze water inside large metal containers, released the solid blocks, and moved them into cold storage. By the beginning of the 20th century, manufactured ice was replacing much of the natural product. Household ice delivery continued because millions of families still owned iceboxes, but the blocks arriving by wagon increasingly came from a local plant rather than a northern lake. Eventually, electric household refrigerators attacked the recurring delivery model itself. A family with a mechanical refrigerator no longer needed an iceman to bring a melting block every few days. The household could purchase electricity and produce cold continuously inside its own kitchen. The natural ice merchant had controlled the lake, the icehouse, the ship, and the delivery route. The refrigerator moved the source of cold into the customer's home. By the 1920s, electric refrigerators were becoming increasingly practical for households. In 1924, the final commercial ice harvest was taken from Rockland Lake, ending an industry that had once supplied a substantial share of New York's cold. The old infrastructure disappeared remarkably quickly. Icehouses were abandoned or demolished. Delivery horses vanished from city streets. The specialized knowledge of reading pond ice, cutting grids, and packing blocks became unnecessary. But the natural ice industry did not fail because ice stopped being valuable. It failed because cold became easier to manufacture. The demand tutor helped create continued growing. People still wanted chilled drinks, preserved food, ice cream, cold beer, and fresh meat transported across long distances. The new refrigeration industry inherited the market that natural ice merchants had spent a century developing. Their product vanished, but their economic system survived. Modern refrigerated warehouses, supermarket freezers, reefer trucks, restaurant ice machines, and temperature-controlled shipping all perform versions of the same task, moving heat away from valuable products and purchasing additional time. That was always the real business. The 19th century ice merchant appeared to sell frozen water. In reality, he sold slower spoilage, longer transportation distances, more comfortable summers, consistent brewing, safer storage, and access to markets that had previously been unreachable. He sold time by the pound. And the most remarkable part of the industry was not that people learned how to preserve ice. Humans had stored winter cold for centuries. The remarkable part was that entrepreneurs connected frozen ponds, waste sawdust, seasonal workers, horses, icehouses, ships, tropical ports, delivery wagons, and household cabinets into one coordinated chain. At the beginning of that chain, winter produced something almost free. At the end, a customer paid a premium for what remained. Everything in between, the cutting, standardization, insulation, storage, speed, distribution, and creation of demand, turned frozen water into white gold. That was the economics of ice before refrigeration.